Hi guys, dear students, I'm back once again. Myself Dr. Manasi Mukhopadhyay, and today we are going to discuss about one of the periodic properties, that is oxidation state and oxidation number. Now, to understand oxidation state and oxidation number, we have to understand that oxidation, what does oxidation mean? Oxidation means the loss of electron. So, wherever and whenever you find the element is losing electron, we will be terming it as oxidation, and on the contrary, on the other hand, reduction naturally is the opposite one, that is the gain of the electron. Now, substances that are responsible for oxidation are called oxidizing agent, and the substances which are responsible for reduction are called reducing agents. Now, we all know from the very childhood only, we are just knowing that oxidation and reduction are such processes that they are, they act at the same point of time. Oxidation and reduction occurs simultaneously. Now, the substance which reduces, leaves electron is said to be oxidized, and the substance which gains electron is said to be reduced. And on the other hand, increase in oxidation number, we can, oxidation and reduction can be represented in various ways. Loss of electron means oxidation, gaining in oxidation number, increase in oxidation number means oxidation. On the other hand, gain of electron is reduction, and decrement in oxidation number is called reduction. Oxidation state is the number. Now, this is about oxidation and reduction. Now, what is oxidation state? Oxidation state is the number of electron an atom appears to have gained or lost. This is the number of electron that is involved during losing or acceptance of it. The number of electron it reduces, it leaves, the number of electron it leaves gives to its oxidation number, or the number of electron it accepts leads to its oxidation number. So, oxidation number is nothing but the number assigned to an element in a compound. Oxidation number is the number that is assigned to an element in a compound. And what is that number? That number is nothing but the number of electron gained or left by the compound or the element. Now, there are several rules how we can assign the oxidation number. Rule number 1 is, in free element, the oxidation number is 0. For example, sodium, copper, phosphorus, hydrogen, sulfur, chlorine, these are free elements and they are assigned an oxidation number 0. What is a free element? A free element is one which can exist on its own without the assistance of the other element, and it is also neutral, so it will have neither loss nor gain of electron. This is rule number 1. Talking about rule number 2, the sum of all the oxidation numbers in a molecule has to be 0. That means the molecule itself will be having an oxidation number of 0 in such a way that the elements present in it must be arranged in terms of their oxidation number in such a fashion that overall, by summation, the compound will have an oxidation number of 0. For example, KMnO4. KMnO4 is a compound which comprises of potassium, manganese and oxygen. The oxidation numbers of potassium, manganese and oxygen should be assigned in such a way that as a whole, KMnO4 will have an oxidation number of 0. Coming to ammonium sulfate, NH4 whole twice SO4, it is also a compound, and the compound itself is having an oxidation number 0 in such a fashion that ammonium, sulfur and oxygen, the elements or the ions present in it, must be assigned in such a fashion oxidation number that summing up all of them will give the oxidation number of the compound 0. Rule 3, the oxidation number of a simple ion is the charge on that ion. For an ion, for any element, we can say the oxidation number is 0, but talking about an ion, We have talked about a compound, we have talked about an element, now talking about an ion. An ion is having the oxidation number same as its charge. If an ion is assigned +2 charge, its oxidation number will be +2. If an ion is assigned plus charge, its oxidation number will be 1. For example, Cl minus is having oxidation number -1 as Cl is assigned negative charge. Sodium is assigned positive charge, that is alkali metal, it will be having Na plus. When it will be forming ion, it will be forming Na plus. So, naturally speaking, it will have an oxidation number of +1. So is the case of O2 minus, calcium 2 plus, aluminium 3 plus. Aluminium 3 plus is assigned +3 positive charges, so its oxidation number is +3 and so on. Coming to the rule number 4, the sum of oxidation numbers in a complex ion is the charge on the ion. So, considering an ion, oxidation number of a complex ion SO4 2 minus. So, SO4 2 minus as a whole will have the oxidation number same as its overall charge. SO4 2 minus is assigned to negative charge, naturally its oxidation number will be -2. PO4 3 minus will be having an oxidation number of -3 as it has 3 negative charges. Rule number 5. In compounds containing hydrogen, the oxidation number of hydrogen is +1. Always the oxidation number of hydrogen is +1 when it is associated in a compound. For example, H2O, for example, NH4 plus, for example, HCl. In all the 3 cases, the oxidation number of hydrogen is +1. But there are some exceptions. What is that exception? When hydrogen forms hydride ion, in metal, where it is formed? In metals, hydrogen form hydride ion. Generally with non-metals, hydrogen is assigned positive, that is +1. But with non-metals, when hydrogen forms a compound with a metal, when hydrogen forms compound with a non-metal, it is assigned +1. But when hydrogen forms a compound with a metal, it is assigned -1 charge. Example, hydride, sodium hydride, potassium hydride, calcium hydride. In all the cases, hydrogen is associated with metal, either sodium or potassium or calcium, to form the compound, and in all these cases the hydrogen is assigned -1 as the oxidation number. Talking about rule number 6, in compounds containing oxygen, the oxidation number of oxygen is always -2. We must be knowing this, that generally oxygen is assigned a charge of -2. Naturally, it's I told you in the rule number, let me tell you the rule number 4 in case of ions, rule number 3 in case of ions, simple ions. Oxidation number is the number of charge it is assigned to. So, whenever oxygen forms an ion, oxygen forms a compound, naturally it will be assigned -2 charge, so its oxidation number will be -2. But there are exceptions as well. For example, peroxides like hydrogen peroxide, H2O2, sodium peroxide, in all these cases oxygen is assigned a charge of -1. Only in case of peroxides oxygen will be assigned -1, but in all other cases oxygen will be assigned -2. Hydrogen, generally speaking, is having, when it is associated with non-metal, it will be having a charge of +1, and so its oxidation number is +1. But when it is associated with any metal to form a compound, its charge is -1, so it will be having oxidation number of -1. Oxygen, when bonded to fluorine, it is assigned +2 charge. This is rarest of the rare case or anomaly in case of oxygen. Oxygen generally is assigned -2 charge. When it is formed peroxide, when it forms peroxide, it is assigned as +1 charge. But when it is bonded with fluorine, for example OF2, the oxidation number of oxygen is +2. Rarest of the rare case. Rule number 7, alkali metals have 1 electron in the outermost orbit, that is in the S shell. So, they will be forming ion plus, Na plus, sodium plus, potassium plus, all these things, and naturally their oxidation number will be +1. Alkaline earth metals, they are having 2 electrons in the outermost orbit, that is S shell. So, their oxidation numbers will always be +2. Now, what are the alkali metals? Alkali metals are sodium, potassium, lithium, rubidium, cesium and francium. They will all be assigned an oxidation number of +1. What are the alkaline earth metals? Beryllium, magnesium, calcium, boron, radium, all these things, these are assigned +2. Now, talking about halogens. Halogens are group 7 and they are all -1. Why -1? They are ready to accept electron in order to form an octet. So, naturally they will be forming an ion -1, chlorine Cl -1, fluorine -1, bromine -1, and naturally their oxidation numbers will be -1. For example, fluorine, chlorine, bromine and iodine. But there are exceptions as well. When bonded to more electronegative elements, for example, ClO2, Cl is +1 and oxygen is, and Cl is +1 and in ClO2 the chlorine is +4. When bonded to ClO2, Cl generally is having an oxidation number of -1, but when it is bonded to ClO2 bonded to oxygen, oxygen is having -2 charge. So, 2 chlorines will be having +4 charges. That is it. Rule 10, oxidation is decrease in oxidation number. As I said, as I started my lecture by saying this, oxidation is manifested by the decrease in oxidation number and reduction is manifested by the gain in oxidation number. Let us consider a reaction. Magnesium plus copper 2 plus getting converted to magnesium 2 plus copper. Now, in this reaction we can see magnesium, since it is an element, is having an oxidation number 0, and copper in the ionic form having +2 charges will be having oxidation number +2. But after reaction, magnesium is assigned +2 charge, that is it becomes an ion and it is assigned +2 charge. So, naturally in case of an ion, the charge itself is its oxidation number. So, magnesium from 0 is getting converted to magnesium 2 plus. That means its oxidation number increases from 0 to +2. That means magnesium is getting oxidized and copper 2 plus getting converted to metallic copper, that is an element. So, oxidation number from +2 changes to 0 in case of copper. That is, there is a reduction in oxidation number which indicates that copper is undergoing reduction. These are few examples. Sodium oxide Na2O, overall oxidation state is 0, oxidation state of sodium is +1 and +2, and oxidation state of oxygen is -2. In case of individual sodium, it is overall Na2, there are two atoms of sodium. Oxygen is having -2 oxidation number and Na2O as a whole is having oxidation state of 0. So, to make it 0, 2Na has to have the oxidation number +2. That means 2Na has oxidation number +2, 1Na will be having oxidation number +1. Potassium permanganate, KMnO4, let us calculate how it happens. Overall oxidation state is 0, oxidation state of potassium is +1, oxidation state of manganese is +7, oxidation state of oxygen is -2. And there are 4 oxygens, that means overall it will be 4 2s are 8, that is -8. Hence, you calculate there are 8 positive and 8 negative. So, overall oxidation state of KMnO4, that is potassium permanganate, is 0. Now, let us analyze the oxidation state of manganese in following examples. In case of MnCl2, manganese chloride is having oxidation state of +2 because each chlorine is having an oxidation number -1. So, 2 chlorines it will be combined to -2, and in order to make MnCl2 0 oxidation state, Mn has to have an oxidation state of +2. In case of MnO4, there are 2 oxygen and we know for oxygen the oxidation number is -2. For 2 oxygens it will be 2 2s are 4, that is -4, and naturally manganese in MnO4, manganese oxide, will be having an oxidation state of +4 as the overall oxidation state of manganese oxide will be 0. In case of MnO4 minus, permanganate ion, MnO4 minus is called permanganate ion. In case of permanganate ion, we see there are 4 oxygen That means 4 2s are 8. Out of 8, 1 is minus, that means it comes to 7. So naturally, in order to make permanganate ion having oxidation state of 0, manganese has to have plus 7 oxidation state. Now manganese can have different oxidation numbers depending on the elements it is combined with. We can see from this example that the same manganese, in case of manganese chloride, it is having oxidation state of plus 2. In case of manganese oxide, it is having plus 4, and in permanganate ion, it is having an oxidation state of plus 7. So manganese can have different oxidation numbers, but it depends on which metal it is associated with which metal it is combined to. When naming transition metal compounds, it is normal to include the oxidation state in the name. Now talking about the transition elements. Transition elements, they are characterized by variable valency. Naturally, as they are characterized by variable valency, they will have variable oxidation state or oxidation number. And different colors of the transition elements are imparted because of them having different oxidation states. At different oxidation state, the transition elements pose different colors. For example, let us see. Fe2 plus ion, that is ferrous ion. Ferrous ion is having an oxidation state of plus 2 and it is green is color. Example, ferrous chloride. Now talking about ferric ion, it is having plus 3 charge. So naturally it will have an oxidation state of plus 3 and it becomes yellow in color. For example, ferric chloride FeCl3. Manganese, we have seen in this example that manganese possesses plus 2, plus 4 and plus 7 oxidation states. Let us see in 3 different oxidation states what are the colors they are imparting. Manganese in 7 oxidation, plus 7 oxidation state, it is pink in color, permanganate ion. Manganese in plus 4 oxidation state, that is manganese oxide, is brown in color because of having plus 4 as oxidation state. And manganese in plus 2 state, for example in manganese chloride, is colorless, where it is having an oxidation state of plus 2. But whatever rules we have discussed so far, there are deviations from this, there are anomalies in it. Let us have a brief idea about the anomalies, a few of the examples of the anomalies. For example, if we take a compound Na2SO4S4O6, how many sulfur atoms are there? How many sulfur? There are 4 sulfur atoms. So let us assign these 4 sulfur atoms as S1, S2, S3 and S4. There are 2 sodium, one in the left hand side and the other in the right hand side. You can see from the picture there are 6 oxygen atoms. So sulfur 1 and sulfur 4 each will be having 3 oxygen atoms. That is counted to, this is a symmetric structure, that is counted to as a whole 6 oxygens. Now Na in both the sides will be having plus 1. The 2 oxygens out of, let us talk in this way, that out of 4 sulfur atoms, S2 and S3 are bonded to 2 other sulfur atoms and their oxidation states are 0. S1 and S4 are bonded with oxygen atom, which results in the oxidation state of plus 5. Why plus 5? One oxygen is having minus sign and 2 oxygens will be having 2 minus 2 as oxidation number. So 2 oxygen minus 2, that means 4 minus 4, and 1 oxygen is having 1 negative charge, that comes to minus 5. So as it is associated with the oxygen which is having minus 5 as oxidation number, naturally S1 will be having an oxidation state of plus 4. 1 is remaining, 1 is minus, that means the whole negative charge is not been neutralized by the oxidation number of sulfur. How many of neutralized? How many of the oxygens are neutralized? 2 are neutralized. That means 2 2s are 4. Minus 4 is been neutralized. 1 is left as minus oxygen. So sulfur S1 will be having plus 4 as oxidation state. And so is the case for sulfur 4. Sulfur 1 will also have plus 4 oxidation state. Sulfur 4 will also have 4 oxidation states. But sulfur 2 and sulfur 3, as assigned before, will be having oxidation states 0. Let us talk about the other anomaly, that is CrO5, chromium oxide. How to calculate the oxidation? Let us calculate the oxidation state of chromium. And since we don't know what is the oxidation state of chromium, let us assign it as X. Generally, we assign X for the unknown quantities. So, let the oxidation number of chromium be X. Then, the oxidation state of each oxygen in peroxide is OO, that is -1, as we have discussed in rule number 2 or 3 probably, that the oxidation state of oxygen in peroxide are -1 and remaining 2 oxygens will be having -2. So, the oxygen at the top will be having an oxidation number of -2 and remaining 4 oxygens each will have an oxidation number of -1. So, total what is the oxidation number of all the 5 oxygens? 2 plus 3 plus 4 plus 5 plus 6. So, it is -6 for all the 5 oxygen atoms, 4 of which are assigned -1 and 1 is assigned -2. So, 4 plus 2 that came 4 plus 2 that comes to -6, -4 plus -2 that comes to -6. So, naturally chromium will be having an oxidation number of +6, as simple as that. So, from the discussion we probably or hopefully had an idea about the oxidation number, oxidation state of different elements, compounds, simple ions and complex ions, and how they are formed, what are the anomalies, what are the exceptions, and finally how to calculate the oxidation number in a compound or in a complex ion. And with that note, I would like to end up my lecture for this session. Thank you so much for watching me. Thank you.